Well, welcome everybody. We're continuing with our session on technology and sustainability with a wonderful speaker, James Ehrlich, who has the fantastic title of Director of Compassionate Sustainability at the Stanford University School of Medicine. Interestingly, interpretation of compassionate sustainability in his work has taken him to an AI-based form of community development, which he's going to tell us about now. I'm so happy to have you, James. Thank you for being here, and take it away.
Thank you so much, and I'm glad we were able to get over some of the technical issues, but wonderful to be here with everybody. Yes, I am James Ehrlich. I am Director of Compassionate Sustainability at the Center for Compassion, Altruism Research and Education at Stanford Medicine under Dr. James Doty. I'm also founder of a Stanford spinoff company called Regen Villages, and I'm going to be demonstrating here our Village OS software, which is really about how we live and where we live that can improve healthy outcomes, but also it's about how can we de-risk residential real estate development using generative design for machine learning, but also to create communities that are climate adaptable and resilient, right? So let me just log in here and we'll get the demo going. And we're off to the races.
Love that you're giving us a demo. Thanks for this.
Yeah, sure. So, so basically, in this scenario, you can play the role, and by play the role, I mean you are a stakeholder. You are a stakeholder as a landowner who's typically asset rich but cash poor, so you're risk averse. You are a residential real estate developer who's also pretty risk averse in terms of capital outlays for expensive planning and kind of storytelling about land, especially trying to understand feasibility. You are maybe a municipal government or regional government, the typical seats of power, making decisions about land developments. You could also be using this software. Or maybe you're an architect, engineer, or planner who wants to find a better solution, right? So in this scenario, you're going to see a project that we've been working on. It's one of the smallest projects, actually, we've been involved in. It's a small community off the east coast of Massachusetts called Martha's Vineyard. Maybe you've heard of it. It's a high net worth location. Obamas, Kennedys, other kinds of high net worth families live there. The problem that they have here is very similar to places all around the world, is they have a lack of social affordable housing inventory, which means that people who have to work on this island have to commute by ferry to get back and forth. So in this particular situation, what we're seeing here is the actual data of the land parcel information and boundaries. This is this 33-acre parcel of land that the family office owns. The first thing we do is we go through an annualized analysis of everything related to open source data about this land and this area and this location. So property limits, topography, protected habitats, ground temperature, humidity, sky coverage, illumination ranges, which is relevant to solar panel placement. We look at wind speed, wind direction, relevant to, excuse me, wind turbine, residential turbine placement, and also precipitation, storm surges, sensitivities to this, precious lagoon areas. We look at soil mapping, census data, housing prices, even traffic patterns. There is a treasure trove of open source data now around the world, and it's very exciting for us to be able to bring this to life, right? So the first thing we do is we extrude out that 33-acre parcel in a kind of game-like engine, right? So we can actually see, where does this land fit in the wider community itself? Then the first thing we do is we give the stakeholders this ability to sort of designate what are called retained features and key locations. Retained features can be, for instance, archaeological sensitivities, indigenous or wildlife corridors, servitudes, things like this. Key locations, we put pins in the ground where the best location for the entrance would be, where we would pick up district water, where we would pick up district energy, a grid tie. If there's a sewer tie in that situation, many times we want to digest our own waste, but that's one of the things that we look at. We then look at what's called permaculture. Permaculture is really the study, in many ways, of land contour and shape related to natural resource flow and natural capacity. It's really fascinating because it's this sort of indigenous wisdom, if you will, related to soil and sediment and farming practices. And this is where it starts to get really exciting, because we can connect now to foundation and large language models that allow us and the stakeholders to ask questions of the modeling, but also the software can ask questions back to the stakeholder. And then we can start to shape, if you will, these objectives. What's the best use of this land in terms of climate resiliency, in terms of all the different aspects? And it can start to create these suggested systems and service overlays for where those things can be placed on that land. Once we understand the snapshot of place and land, we go right to water. And the water capability has everything to do with the topography and the contour of the land. So actually, this is all the real world data of this particular parcel of land, where we can harvest the water, where we can look at the capture for water ponds and aquaculture, how we can digest waste into these reed beds for effluent flow, what are called living machines. And then once we have a snapshot on that, it can absolutely start to suggest and infer what is the best case scenario? How many families could we actually put on this land while being able to hydrate them and feed them and empower them through these services, right? Now, we also do is we ingest the rule books. We understand zoning, we understand building heights, building codes. There's a treasure trove, again, of this open source data, being able to aggregate that data so we can start to really model and say, hey, originally we understood that we could only put 19 homes on this land, single family, 1 acre plots. However, based on the height restrictions and the roof space, we were able to actually show that we could put 20 apartments, including senior living. We could put up to 80 townhomes, plus an additional amount of single family homes and tiny homes on that land. So we're actually able to show how we can hack the rules based on understanding this information. Once we understand the demand side, we're capable then of looking at the infrastructure. In other words, what do we need to actually run this neighborhood? Biogas, biomass, solar, wind, energy efficiency. What are the systems and services, including the companies that are providing these systems and services? What are their costs? What are their mean time before failure? We can actually model all of these things virtually, right? It gets really super exciting to see these particle generators doing their work in terms of how these systems and services will work for these communities. We then skip right to the what we call preliminary render of the community, and you can start to see here that a farmer, a landowner, without any skills, architectural skills, planning skills, engineering skills, can actually sit around a coffee table with their family members and start to come up with these ideas for a productive use of their land that respects the conserved value, the productive farming value in terms of food security, the water value in terms of water security and waste digestion, sensitivities also to these kind of lagoon areas, but also that we can show financial modeling for how these communities can generate positive rates of return, but also provide social affordable housing access. And then the next step really are these really immersive, high fidelity rendering outputs, where essentially we can start to look at what is it like to live in these neighborhoods as a child, as a young person, as a young couple, as a elderly, as a senior couple. Not only that, but what is it like in terms of season? What's it like to live there in the spring? What's it like to live there in the summer? What is it like in the autumn, including fluid dynamics with rainfall and water flow and being able to recharge these aquifers and prevent flooding and things like this? And also in this particular part of the world, we understand that, of course, it's going to, excuse me, it's going to snow. So how can we best understand, excuse me again, how to design for these kinds of climate-based communities using machine learning software and generative design? Moreover, how can we show how these neighborhoods are going to generate positive rates of return, not only for the investors in this community, but how it reflects neighbors' property values? Very big on that NIMBYism thing, not in my backyard, folks. Most importantly, we can show sovereign wealth, pension funds, and institutional funds very clearly how a portfolio of their land holdings, their land assets, can be reimagined through the VillageOS software to be able to show ESG, SDG, climate metrics, which are critical now for their portfolios. ESG is environmental social goals and governance, SDG, sustainable development goals, and of course, climate metrics. We can then show very, I would say viscerally, how a neighborhood like this can really be a benefit in terms of reducing burdens on government, create additional housing inventories, especially affordable housing inventories, provide an oasis for the neighbors for food security, water security. We have to predict now, not if, but when district utilities and services are going to fail more and more, and how those cascading effects are going to be burdened. We're seeing all of those things happening now at more force around the world. So, ladies and gentlemen, happy to introduce to you the VillageOS software from Regen Villages. We're continuing to build out the software. We're currently raising our pre-Series A round. So happy to speak to anybody who's interested in investing in the future of residential real estate development, especially driven by prop tech, contech, and ag tech. And just before I finish this demonstration, to say the software is not only a design implement, but also once it's done designing a community, it can act as an in situ neighborhood server to actually help run the neighborhood infrastructure. So look at it as your kind of friendly virtual neighborhood facilities manager. Predicts issues, can fix them in advance, and also with the future of robotics, be a very exciting piece. So I'm going to leave the presentation there.
Thank you so much, James. That's a fascinating demonstration of a number of things, including the potentiality of visualization software in the current technology era we're in to demonstrate what's possible with land development, but also how it integrates with AI that pulls in an extraordinary range of data sources. Now, for me, that's very relevant for a variety of different projects, but your specific use of this is to aim to build self-sustaining communities that really contribute to a bottom-up climate action in effect. Am I right about that?
That's absolutely correct. And really what it comes down to is what are called microgrids, which are essentially load balanced shared power. So each house is capable of generating more power than the family needs. They're passive home design, but they're also with heat pumps and solar and other kinds of technologies are capable of generating more power. If you connect them and interconnect them in a neighborhood context, they become a power source, a power station that generates more power than the community needs. That can then be a supplement to the grid, but it can also be, when the grid goes down, this wonderful resource for adjoining communities.
Right. It's amazing that you presume that almost any community could be self-sustaining and that you have all this data to back that up, and you can actually show developers what would be possible. But it's a little misleading to show Martha's Vineyard, because in fact, you're really thinking of this as a tool that can be used, especially in the developing world. So talk a little bit about some of the places where you are currently working on actual projects beyond the one in Martha's Vineyard, and what your vision is for the ultimate aim of this whole project.
Thank you so much. It's such a great question. Yes, obviously we modeled and showed this particular example for Martha's Vineyard because there are some pain points there with that specific family office and their land. The largest project we're working on is actually in South Africa, 1,200 homes on 200 hectare, about 30 minutes from Pretoria, working with a South African and African landowner who's also a farmer. But it's really exciting because the 1,200 homes is on less than 10% of that 200-hectare parcel. The majority of the land is bioproductive, designed really to sustain not only the people who live in that community, the 1,200 families, but also can be a resource for the adjoining communities as well. So we're really looking at sub-Saharan Africa, ASEAN, MENA, this idea that we can create these communities that can stem climate migration and address refugee crisis around the world. So what does that do? It lowers burdens on governments. It lowers burdens on communities. It brokers peaceful, happy places. This whole topic, by the way, of compassion sustainability coming out of Stanford University, which is really such a blessed thing from CCARE, is this whole idea that we can use technology to imagine neighborhoods that actually create healthier long-term outcomes.
Right. It's really a wonderful vision. I assume the data sets may not be quite as rich in Johannesburg vicinity as they are on Martha's Vineyard, so you must encounter some challenges there. But we're not loaded with time, and maybe you can address that in a minute. But one of the things that's very interesting, even about the demonstration you showed us, is you said that was zoned in a certain way, but in fact, your visualization and data integration shows that in fact, it can sustain a much larger density of development and be self-sustaining. So in effect, you end up challenging existing zoning, which in many cases was very primitively arrived at a long time ago. So talk a little bit about the implications of what you're learning on the current regulations around land use.
Let me just put it this way. All the rule books exist. They're not black box, but they live in many places and in different formats. And in any case, they typically rely on people, on humans, to interpret those rules, right? So machine learning loves this complexity, to ingest all these different rule books, to put it into a very clean, safe kind of repository, where eventually we can crawl that data and create, I call it like a Buckminster Fuller, if you will, overlay of what's possible. It's a new kind of interpretation, but that allows the government to say, yes, we want this kind of community. It allows the neighbors to say, yes, this is a good benefit for our property values. It will be a good enhancement for us. It allows the financial folks to say, yes, this is absolutely what we need right now.
Yeah, well, your belief is clearly that this kind of self-sustaining eco-community can exist almost anywhere, but your ability to demonstrate that, in effect, will likely challenge the way that zoning is managed in many, many places. And probably in some of the parts of the developing world, the zoning is a lot more loose. So you have a lot more flexibility there. But just give us some final thoughts. We're running out of time, but I really think it's wonderful that you're interpreting compassion in this extremely creative way in order to address the global climate crisis.
I don't want to bury the lead here. The bottom line is we've raised 2 million euros since 2016 from lovely, wealthy family offices, impact investors, strategic partners, mostly in Europe and the UK. We're looking to raise about 6 million euro right now for a pre-Series A round. Really hopeful to meet those kinds of investors who care about the future of residential development, and in a really exciting way that we're taking game engine technology, powerful data sets, and being able to marry that together for the simplicity to democratize the whole process. Thank you so much.
I didn't, in introducing you, say that you actually came out of the gaming industry, which is fascinating. Well, I would love to see more sustainable development around the world, and you're showing that it could possibly happen a lot faster than most people think. So thank you so much.
David, this is really amazing. I appreciate you so much, and especially for your patience in getting through all the technical stuff. We did it. Thank you.
Yes, thank you to our audience for your patience. And I believe now we're going to thank you so much. I believe our next speaker is Bill Gross. Am I right about that? I believe. Okay, and we're going to stay right in the same video.
And I'm going to head out, and thank you so much for a wonderful time.
Thank you so much, James.